Introduction to Question 3. A system contains a sender and a receiver. Each frame carries 2000 bits, which composes of a sequence number and data bits. The distance between the sender and receiver is 4000 kilometers and the propagation speed is as shown. The channel bandwidth is 500 kilobits per second and is full duplex. The overhead due to the header and trailer is ignored. A timer is started when a frame is entirely sent out and the time out of a frame is 100 milliseconds. Question 3a. Go-back-N ARQ protocol is used with the maximum allowable window size in the sender. 3-bit sequence number, starting at 0, is used. That means sequence number 0 to 7 are used. The receiver acknowledges immediately when an information frame is received completely. The processing delay on the both sides and the transmission of time of AC and NAK are ignored. The source has 11 data frames to be sent. It is known that the 3th source frame is lost in its first transmission and its retransmission, and all other frames are transmitted and received successfully. With aid of a timing diagram, evaluate the total time required to complete the data transmission. All frames are transmitted and acknowledged. Question 3b. Repeat question 3 with selective repeat ARQ protocol. In question 3a, we are using Go-back-N ARQ. 0 is the time that sender sent the first bit in the first packet. The bit travel along the cable and reach the receiver at 20 millisecond. All data frame have a transmission time of 4 millisecond, therefore, at 4 millisecond. The last bit of the first packet is sent from sender and the first bit in the second packet is being to be sent from sender. At 24 millisecond, receiver received the last bit of the first frame. Therefore, it sends AC1 back to the sender. The sender will receive the AC at 44 millisecond. We will go back to this later. And so on. The frame F2 is lost. At 12 millisecond. The first bit of frame 3 is sent from sender. At 16 millisecond, the last bit of frame 3 is sent from sender. At 36 millisecond, the receiver received frame 3, but it wants frame 2. In Go-back-N ARQ, it will discard the frame and send back the AC with the expected frame. At 56 millisecond, the sender received AC2. However, the recipient of frame 2 has already been acknowledged. Therefore, the sender will ignore this AC. The red line on the left-hand side are the timeout timers. We will go back to this later. At 44 millisecond, the sender received the AC1. It moved its window and therefore sent frame 7 to the receiver. However, the receiver does not expect frame 7 but it wants frame 2. It will be discarded. The same goes for frame 0. Note this frame 0 is not a resend, but it is just a reuse of sequence number. Recall that our sequence number of 3-bit, from 0 to 7. At 56 to 92 millisecond, the sender received AC2, but it is expecting AC3. Note that the timeout timers are going to expire. We will go back to this later. From 112 millisecond to 152 millisecond, the timers are expiring and therefore the sender start to resend the frames. At 136 millisecond, the receiver received the last bit of frame 2 successfully. Therefore, it sends the next expecting packet, 3, along with the AC, and so on. Finally, at 204 millisecond, the transmission is completed. At 0 millisecond, the sender send frame 0 to the receiver. The first bit of the frame will reach the receiver at 20 millisecond. At 24 millisecond, the receiver received the last bit of frame 0. As we are using selective repeat ARQ, the receiver will send the sequence number back to the sender. Frame 2 is lost. At 36 millisecond, the receiver received frame 3. In selective repeat ARQ, the frame will be accepted. At 44 millisecond, the sender received DAC0. Sender slide its window, and start sending frame 4 to the receiver. Same for frame 5. At 56 millisecond, the sender received DAC3. The sender have 2 at beginning of the window, therefore the window cannot move, and sender becomes silence. Same for AC4 and AC5. Note the red line on the left-hand side. It is the timeout timer for frame 2. At 112 millisecond, the timeout timer for frame 2 expires. Therefore, the sender resend frame 2. At 136 millisecond, the receiver receive frame 2 completely and send AC2 back to the sender. At 156 millisecond, the sender receive the AC2, and it move its window to frame 6, as frame 3, 4 and 5 are acknowledged. As 6, 7, 8, 9 are not sent, the sender starts sending them, and so on. Therefore, the transmission will complete at 244 millisecond.